So today, we're diving into one of the most fundamental machines in any workshop, the conventional metal lathe. This beast is a powerhouse of precision, capable of turning a boring old chunk of metal into a beautifully engineered part. Let's get right into it.
And here she is. You can really think of this machine as having two main characters. On the left, you've got the chuck. That's the part that grips the metal and spins it like crazy. And on the right, you have the carriage, which holds the super sharp cutting tool. The real magic, the real art, happens when we control exactly how that stationary tool meets the spinning metal.
So that's the big question, isn't it? How do you take a simple metal rod and shave it down into a part with dimensions that are accurate to a fraction of a millimeter? How do you command this powerful machine to get a perfect result every single time? Well, that's exactly what we're about to break down. To really get how a lathe works, you only need to understand one core idea: rotation. It's pretty simple, really. The lathe spins the metal workpiece at a high speed, and then a fixed cutting tool is carefully brought in to touch it. By controlling that tool's movement with incredible accuracy, we can literally peel away layers of metal.
Right, so the textbook definition says it rotates a workpiece to perform operations like cutting, sanding, or drilling. We're going to focus on cutting today, which is often called turning. But just keep in mind that this same basic principle is what lets you do all sorts of other cool stuff, all with that same amazing precision.
Okay, hold on. Before we even think about flipping the power switch, we have to talk about safety. Seriously, this is absolutely non-negotiable. A lathe is an incredibly powerful tool, and you've got to respect it. These aren't just tips, these are the absolute must-follow rules of the workshop.
Let's run through these, because they're crucial. First off, never, ever stand on the far side of the lathe. The chuck spins towards you, so if anything were to ever come loose, you want to be well out of that line of fire. It's also just common sense to keep your hands and any loose tools far away while it's running. When you turn it on, use the handle and then get your hand away. And finally, and this is a big one, your movements on the control wheels need to be slow and smooth, always. Rushing is how you make mistakes and get a really bad finish.
Now this right here, this is a fantastic pro tip. The little bits of metal flying off, the chips, they tell you a story. If the chips are silvery, you're doing great, you're in the zone. But if they start turning blue or brown, that's the metal screaming at you that there's too much heat. It's a sign that your speed is way too high or your depth of cut, the DOC, is just too deep. It's the machine itself telling you, hey, back off a little.
All right, with safety covered, we can finally start machining. But the first two steps aren't about cutting down the size. They're all about prep work, centering, and facing. We need to make sure our workpiece is spinning perfectly on center and that its end is perfectly flat. This is the foundation for every single thing we do next.
Centering is this really clever, methodical process. You just lightly touch a piece of chalk to the spinning rod. You'll instantly see where the high spots are, because the chalk will only mark the part of the rod that's sticking out. So you stop the machine, adjust the chuck screws on that chalked side to nudge it back towards the center, and you just keep repeating that until you get a perfect, unbroken chalk circle. That's how you know it's spinning perfectly true.
Next up is facing. This is how we get a perfectly flat surface on the end of our rod. To do this, we use the cross slides wheel. The cross slide is what moves the cutting tool towards and away from the center of the workpiece. So we'll start at the very outer edge and just slowly, carefully, feed the tool across the face, shaving off a super thin layer until it's perfectly smooth.
And look, I really can't say this enough. Every single movement, especially when you're doing these facing and finishing cuts, has to be as slow and as smooth as you can possibly make it. Any little jerk or hesitation in your hand is going to get copied by the cutting tool right onto the surface of your metal. Patience really is the secret ingredient here.
Okay, our workpiece is perfectly centered and faced. It's prepped and ready to go. Now we're on to the main event. This is called turning, and it's the process of reducing the rod's overall diameter to our exact final dimension.
So for our example here, our mild steel rod is starting out at a diameter of 25 millimeters. You know the old saying, measure twice, cut once. We double-check this with calipers before we make a single cut.
Our goal is to get this down to a final diameter of exactly 22 millimeters. That means we need to remove a total of 3 millimeters. But here's a crucial detail. The tool only cuts on one side, which means it's working on the radius. So to reduce the diameter by 3 millimeters, we only need to cut 1.5 millimeters deep. That's a key concept.
Now, how do we know where to start cutting from? This is the most critical step. You have to slowly bring the cutting tool in until it just barely kisses the surface of that spinning metal. The very instant it touches, you stop.
That's it. That is your 0 point. Every measurement from here on out is based on that single reference point. So let's make the cut. Once we've set that 0 point, we're going to do this in 2 passes. First up is the rough cut. We'll dial the cross slide in to 1.25 millimeters. This is to get rid of most of the material quickly. Then we use the big carriage wheel to move the whole tool assembly down the length of the part. After that, we do a finish cut. We'll dial the cross slide just a tiny bit more to our final depth of 1.5 millimeters, and we make one last super slow pass. That's what gives us our perfect dimension and that beautiful smooth surface.
As you can probably tell from that whole process, running a lathe is so much more than just turning some wheels. It's really a craft. It's about developing a feel for the machine. You start to listen to its sounds. You watch how the metal peels away. It's almost like having a conversation between you, the cutting tool, and the workpiece. And this really sums it all up. Real precision doesn't come from being fast. It comes from being patient and methodical. It's all about observing what's happening, listening to the machine, and making these tiny, controlled adjustments. Letting the color of the chips be your guide is the perfect example. You're working with the machine. You're not trying to force it.
So there you have it. We've taken a raw piece of metal, and by following this very precise, careful process, we've shaped it into something totally new. The lathe is an incredible tool with almost limitless potential. So now that you know the fundamentals, what will you shape next?